So welcome everybody to this Active Archive Alliance webinar entitled The Rise of Secondary Storage and the Role of the Active Archive. Let me introduce myself. I am Rich Gadomski. I'm the head of tape evangelism for Fujifilm Recording Media USA, and I'm also the co-chairperson of the Active Archive Alliance. And for this webinar, I'm glad to be joined by Bob Cohn, Director of Marketing, co-chairperson of the Active Archive Alliance for SpectraLogic. Welcome, Bob.
Hello, Rich, and hello, everyone. Thank you. Good to be here.
Yeah, thanks, Bob. And we have an industry rock star with us today, data storage expert, analyst, author, consultant, Fred Moore, president of Horizon Information Strategies. Welcome, Fred.
Thank you, Rich. Thank you, Bob. Glad to be here.
So Fred will definitely be the star of today's webinar, and will talk to us about the rise of secondary storage and the role of Active Archive. But before we do that, let me give you a quick intro to Active Archive Alliance. So the Alliance was founded in 2010. Our goal is to promote simplified online access to all data throughout its life cycle. We seek to align education and best practices to meet evolving requirements for data management and archive. And our tagline is modern strategies to solve data growth challenges, which I think really says it all. And we'll hear a lot about how Active Archive supports that modern growth challenge from Fred. So just to share with you who our current members are, they include the companies listed on this slide. And you'll see that these companies represent data media, hardware, as well as software. And now let me turn it over to Fred Bon Jovi Moore. Go ahead, Fred.
What an introduction to a webinar here, Rich.
I was going to say, Fred, you should be wearing sunglasses.
Okay. You guys just let me know how much I owe you for all that, and we'll be good here with this. But what we're doing today, we're going to talk about why secondary storage and active archiving has become such a big deal. And if we could move on to the next chart here, we're going to get a better feel for that. This is the rise of secondary storage. It's really based on what's happened in the zettabyte era. This era began around 2016, and in that year, for the first time ever, the storage industry shipped 1 zettabyte of capacity combined between disk tape and solid state disk. And it'll probably end at the current growth rate. Here we use 27.5% a year. You know, by the year 2043, we'll be talking about the yottabyte era. So it's big. There's a lot of data here. I've got some examples of exactly what a zettabyte would take in terms of various units of capacity. The one that always catches my mind, of course, is in the upper right-hand corner here, 55 million LTO-9 cartridges, non-compressed, to hold a zettabyte of data. And you can look and see some other data points here that give you an idea how big the zettabyte is. We're right now about 7 years into the zettabyte era, and by 2025, we're going to have, looks like most projections showing around 8.4 zettabytes of data actually stored in the world. Remember, we hit the zettabyte number in shipments in 2016, and here 9 years later, there's 8.47 or 8.4 zettabytes stored already. We also know that about 75% of that data is generated outside the data center, and about 80% of all this data is going to wind up back in the data center. It won't be on your PC and your phone or anything. It'll be back somewhere into a cloud data center or a corporate data center. So the dynamics are big here. The stakes are huge. The numbers are so big that secondary storage by itself now accounts for about 80% of the world's digital data. So what's going on to help create this? Well, one of the things is the new apps that are out there. I mean, unbelievably, you can look at what's happened here. LinkedIn took 7 years and 11 months to reach 100 million users. Last December, ChatGPT did it in 2 months. And in the past 3 weeks here, Threads has done it in 5 days. And every one of these new applications that we don't traditionally think about are generating a lot of data. I mean, every tweet, accept, swipe left or right, post tag, friend, or like. Whatever you do on that screen for social media is going to generate some amount of data. And it begs the questions: how much data is being generated by these apps? How much is stored? Where is it stored? And is there any value to this data? A lot of people question the value of a lot of the social media data. So we're going to take a look at a lot of these things as we go forward here.
And Fred, I know you made an interesting comment on that last slide, the fact that a lot of this data is ending up in corporate data centers. And that's something I think people don't think about. Could you say another word or two about that?
Yeah, a lot of this data, after it's used a little bit in your appliance, whatever, it's going to leave and it's going to go somewhere else. And that's usually back to its final resting place. And one reason, that's a good point, Bob, is that these apps on the left on this chart typically generate data that you look at for 2, 3, or 4 or 5 days. You count how many likes, how many people love you, whatever, and then it goes cold. It goes right into archival status, and that's taken off of your phone. You ship it off to the cloud or somewhere else. So very good point. We've got a quick archival path out of this data, and it's much quicker than the path to archive status for most other pieces of data.
Yeah, interesting.
Okay, let's take a look at our next chart here. This chart is in here just to show you what's going on with secondary storage from 2025, which unbelievably is just around the corner and beyond. But secondary storage is really the world of archive. We call it persistent storage, designed to keep less critical data on very economical, secure, and mass storage mediums. And that stuff doesn't need to be accessed as frequently as data in primary storage. So if 80% of your data is archival secondary storage candidate, it is clearly the largest and fastest growing storage tier. A couple key points to bring out of this is that about 80% of all stored data is lower activity archival data, but it can become active at any point in time. And that's something that we haven't addressed too well in the past, and it's going to fall into the category of active archive, which we're going to dwell and drive into a little bit deeper here. Another thing about archive data, it's typically the only copy of data. So you don't protect this like you do online data, databases, mission critical applications. Archival data is very exposed. One copy, if you lose it, it's gone. And we are living right now under the premise that archives have a lot of value, but we just don't know when or where it will become active. So when it becomes active, the value goes way up. And with one copy, we've exposed potentially very important active data that we haven't really mined yet. The other thing is that retention periods are very long. 100 years or more are now very common for a lot of data. You know, all the sports data of Super Bowls, that's going to last forever. Those aren't going to go away, among many other things. And the bottom line here is we shift the next 5 years through this decade in the massive secondary storage and archive world. The active archive is very likely going to become its own de facto standard tier. And of course, the archival world is the world of secondary storage. And this chart is really more of a developmental chart for the storage suppliers in our business here. But the key components are price, performance, capacity, reliability, availability, throughput, and the security features. You can look and see what each of those are in these categories as you get to go back and review these charts later on. And underpinning everything in secondary storage is the sustainability conversation. We should all know by now what technologies use energy, which ones don't, where the benefits are by moving data from energy inefficient to energy efficient technologies. But the tenets listed above up here are the things that we look at for the ultimate long-term solution to store secondary storage data on. And these are some of the key things. Right now, no one technology does all of this. So we have to use a combination of technologies to meet the secondary storage world. And that primarily means disk and tape combined in some fashion. But this is what we're going to be building on for all the vendors going forward, is how to bring this together into a more unified architecture than what we have right now. So when does data become archival? This is a key thing. Most data, if you follow from left to right on this chart, the longer it goes without being accessed, the more likely it is to become archival. The red line coming down and sweeping off to the right over here is the probability of access, which drops significantly after the first week of data creation for most data, not all data. Indices, directories, catalogs, databases, reservation systems are hammered all the time, and that data stays on active storage, primary storage, almost all the time. And that's about 20% of the world's data. But again, the bulk of the data is secondary storage, archival, persistent data, and that's where we want to really focus here is. And as a rule of thumb, not everywhere, but generally, after about 90 to 120 days, your data is going to go cold and become archival. So your decision is to leave it on high energy consuming, more costly technology or to move it somewhere else. Today, the optimal solution in that space is tape. So that's our main play in there right now. But throughout time, as we know, data grows every year, 25 to 35%. So the growth rates are somewhere in between those numbers every year since 2001, which was the last downturn that we had as an industry in data generation. So we're somewhere between those numbers right now. We'll see as the year ends what it turns out to be. I personally think it's picking up right now after a slow start this year because the economy is coming back and we're beginning to work off a lot of built up inventory in this process. As data ages, it gets darker. The longer you don't touch data, the darker it gets. It becomes dark data. Data that hasn't been touched in 100 years is very dark, and the candidate may be to move into a deep archive or a time capsule type storage system. Unfortunately, those systems don't exist yet, so we're talking about tape as the player throughout the entire secondary storage hierarchy here as the main place to play here. Okay. So this little chart, the little line on the chart on the left, social media, shows it's got a different curve than our typical applications have. Social media hits archival status in a week or less, almost every time for everything out there. So this is now a big archive opportunity, and all those apps we saw earlier are another primary feeder into growth for secondary storage technologies. Again, disk and tape, with tape being the most optimal of those technologies. Okay. So we move on to the foundation of our storage environment here. Our storage atmosphere really includes the following things. We're going to go from the left over here and look at, by 2025, our 8.4 zettabytes actually stored. 80% of that is archival, secondary storage. That's about 6.7 that we're going to focus on here. 80% of the world's data is a big deal, and it's the fastest growing piece in the whole storage industry. If that data were optimally allocated, either by humans at screens or some intelligent software that we really don't have in place just yet using artificial intelligence, machine learning, things like that, they would place the data about like this. About 10% would be an ultra high performance solid state technology, mainly flash technology today. Another 10% is mission critical data, and that's 20% of the data. The 80% on the bottom is divided up between active archive and archive. So at any point in time of all your archival data, roughly on an average, 15% of that is active, and that should be up on disk. When it's not active, it should migrate back down to tape. But when that data out of the archive gets pulled up to be analyzed and looked at and examined for a week or two or whatever, it should stay up there in the cache for the archive, which is called active archive. As the zettabyte goes on, as data storage pools get bigger and bigger, the need for an active archive gets bigger and bigger. So that's where we're going with this whole thing. On the bottom, you see the final layer here of this, and this on the left is really the antique technology that probably everybody's got in their data center laying around somewhere. This is what we would call, if you hit the next slide here, legacy, unknown, and orphan data. Nobody knows what it is. One company buys another one, and along with it comes millions of files with no owner, nobody knows what, and basically it's in the data graveyard. So we've got to wonder what to do with this. I don't have a number for this on how much data it is or where it goes, if it has value or not. You know, we do have a company that's a member of the Active Archive Alliance that does all that with old formats and standards to look at that. And that's Sullivan Strickler, by the way. I'll just mention their name because they're one of the few companies that live off of these old formats and package that together with a taxonomy that allows you to sort it all out. And then finally, here we have racks, vaults, offline storage that takes physical movement with human intervention to move it. But this is the foundation for the entire storage industry. and how it migrates and how it moves, how we advance the layers independently or integrate them together is what the future here is all about. Okay. So this leads us to that top layer of that archive stack, the active archive. Basically, we're on the path to making this its own legitimate tier here. The active archive really works in your data center to start with. You see the applications being created here, generally stored on primary storage, SSD and HDDs. And then we have the active archive integrated solution below that. That includes intelligent data management software and some technology to move that data off of primary storage into it. Could be the cache buffer directly on the left, which is the active archive technology, to front end on the right, the tape library. And the intelligent data management software, there's probably a dozen packages now that do that in the industry. And they're a huge player to get the right data in the right place here. When data becomes inactive, you ought to move it onto storage that doesn't burn up energy and spin 7x24 and, hit the environmental issues as hard as it does. So this intelligent software is usually policy driven. It'll be AI driven tomorrow when that day comes. And it will move data if you want to go offsite into the cloud, or move it into an air gap technology that's a tape library, or you put it on a truck and put it on a rack somewhere in a remote vault. Those are all options. But the active archive sits at the heart of secondary storage and where it's going to go for. And that's why it's time to take a hard look at this, because this is the control center for basically 80% of the world's data. And we need to get this right. And the Active Archive Alliance, who I've worked with for a long time, with Rich and his people, are trying to put this picture together and make it all much more seamless and integrated. And we're well down that path now. And, the intelligent software and scalable storage, these are the keys to building an optimal archive. If you have 2 petabytes today, it may not be a big deal. If you have 100 petabytes 10 years from now or 5 years from now, you're not going to be able to live without this technology.
And Fred, this is one of the slides that I really like because it brings it home to what we're doing, building data centers. You talk a lot about the software to move between these tiers. How have you seen that software change? Because the technology of tape and disk has been, we get greater density and performance and things of that nature, but it's been very similar throughout the course of time. How have you seen software applications themselves change to take advantage of better tiering and interfacing with the cloud and these new, S3 interfaces and working with object storage, things of that nature? What would you say about that on the software side?
Yeah, Bob, those are great points, because, this block in the bottom, the active archive block, originally is the core components of what we knew 30 years ago as HSM. Mm-hmm. So all the things you mentioned are things that have been added onto that basic HSM architecture to deal with S3, to deal with objects, on-site, off-site, on-premise technology, tag data when you come through there. I mean, the old HSMs in the past never tagged anything. It left you with a giant pile of things that you had to sort through, and it was really tough to find anything in the archive. So these new software products are really your ticket to go find data in the archive much faster than ever before. And, these keep improving and improving. And one day AI will do all this. I mean, there's still a human effort involved here, which is small compared to the price to pay if you don't do anything.
And so that's one of the big advances, wouldn't you say, that it's not just about storing the data, it's actually finding it, using it, mining it, being able to turn that old data into some kind of new value. Is that pretty fair?
Yeah, I like that. Storing data is one thing, but retrieving it is everything. And if you can't find it, big deal, right? So if you put something in your attic and you never see it again, well, you're out. So exactly. Yeah, this is the logic, the intelligence behind managing your entire 80% of your data, your secondary storage atmosphere. And this is why this is key. And the active archive is a lot more than a disk or flash buffer in front of a tape array. It's the software, it's the hardware, it's the integration, it's where you want to store it on premise, in the cloud, in an offsite location that's not electronically connected, using an air gap. You're right, Bob. I mean, this chart is really the template to build your archive strategy right now going forward. The technologies in here may change. Tape libraries, as you know, can change. They can become more intelligent with partitions. The cache buffer may improve considerably over here. as it gets more tightly integrated with the back end of the tape library right now. So data can move directly from tape into these systems without multiple IOs to get it there. This is just the beginning. I mean, my vision in my mind expands a lot on your question, but this is the foundation for managing 80% of the world's data today. And that number is growing, by the way.
Yeah, beautiful.
Yeah, and I think it's also nice to know that it's really, where the data lives within this active archive is transparent to the end user. They can, for them, it's still online all the time. They can access it whenever they want without IT intervention. Yet by policy, it's moving from expensive primary storage to more affordable economy storage, yet always accessible. And I think that's kind of really where the strategy is to managing this data growth, is getting the right data in the right place at the right time, yet keeping it available for the end users.
And those are great points on this. And with that, if you get the right data in the right place, guess what you do? You get a tremendous TCO reduction.
Yeah, TCO reduction. And you know what, Fred, you said sustainability earlier. I think that's really more and more important today.
Yep, huge.
We can all see the impacts of climate change, just outside our windows.
Right.
Okay.
Exactly. Good. Okay. So we look inside that secondary storage component right now. We're going to leave the primary storage out of this conversation for this chart. And we're going to look at our 8.4 zettabyte stored, 6.7 roughly archival. And by 2025 and after, this will start to take shape. An active archive layer within the secondary storage stack. And it will be air gapped with tape or some other deeper archive technology yet to appear in the bottom. So the three sub-tiers here begin to appear. Certainly the top two are in place and moving right now. And management with intelligent software, hopefully with some AI and ML data movers that can move directly between layers up and down, as opposed to reading it into a storage server and writing it back to the layer above or below. That takes a lot of overhead out of the equation. It streamlines it, and we go from a loosely coupled storage pyramid to a tightly coupled one. That's going to take a few years, but the storage vendors have this great opportunity to do that. So the active archive layer, it's today primarily a nearline HDD world. Yeah, that's the active archive. If you want to take HDD out of this and really ramp up the performance of your secondary storage and your active archive, you can put flash in there. And in the future, we'll have, as I mentioned, an optimized active archive that will more tightly integrate the data movement between these layers. But this is a great evolution of technology over the next 5 to 7 years as it unfolds. This is kind of the template, and we're going to see inside the archives here as we go forward how each of these evolve. The bottom layer is not here yet. These are things on the drawing boards. You can see some of those on the left, but they've been around for a while. We've been tracking them. We can keep tracking them, but right now, for the foreseeable future, it's disk, tape, and flash that are going to run this show. Okay. So the hyperscale data centers are a big deal here because there's over 700 of those in the world. They are enormous. Many are over 100,000 square feet. To give you an example, the average Walmart store is 138,000 square feet. So this is how much hardware sits in these environments. Over half the worldwide storage is tied up with hyperscale. So this is where a lot of over half the world's consumption of storage is going into 700 hyperscale data centers around the world. The biggest one, by the way, 10.7 million square feet in China. That's 132 soccer fields, just to give you an idea. That's about 4 times bigger than my hometown back in Missouri, but a lot of hardware in there.
And, Fred, this is one area where I like your title here, how hyperscale data centers reshape the IT landscape, because I'm seeing more and more manufacturers manufacture storage devices, applications, interfaces specifically for the hyperscalers. And then that's coming down from there into the data centers. When you look at this massive amount of storage, There used to be this argument, do I put it on disk? Do I put it on tape when it came to secondary storage? Now the conversation is, do I put it in the cloud? And you don't know what's behind it. You just know that it's being stored on something. It's another data center. What do you think that means for the hyperscalers? What do you think is behind the covers there when they look at storage?
Well, I think when they look at storage, it's all economics. And, they treat a lot of this like the average enterprise customer does on tape today. They're going to move it somewhere and make it accessible and then move it somewhere else later on. That's going to be lower cost for them to manage their expense profile. So, this operates like the tape environment that all of us know and love very easily here. And I think the hyperscalers have figured that out. Everything they do is economically based. They're driving the utilization up of the hardware on the floor. They're moving data that hadn't been touched in a while, like you just said, Bob, to lower cost, move it back when you want to do it. We know the reason behind this. It's really economics, and they're getting every bite they can out of every storage device right now to make this happen. It's maximizing everything. They use a technician in a hyperscale data center on the average will support about 25,000 servers.
Wow.
One person. There's very few people in these things. Take a tour of one, and they just replace and reinsert the technology back in the rack and move on because there's so much redundancy like that. And the user doesn't see really much where their data is stored back there. You mentioned Glacier, I think, as we talked earlier, and ask a customer, where is their data at any given point in time in that structure and flow? And it's going to be a little tougher to answer on that. You know what you pay for, but you don't know exactly where it's stored. So this is a great economic strategy for them, but it's a challenge for everyone else if you want to dig a little deeper on that. So sustainability, energy, go ahead.
Just saying interesting stuff.
Yeah, it is. They do things differently, and they're over half the world's storage demand in this. We have to acknowledge hyperscale today is the single biggest storage market because of their tremendous amount of consumption. And the United States is not the only place with hyperscale data centers. 15% of them are in China. So we've got to acknowledge that hyperscale is the dominant consumer of storage and servers, network bandwidth, and probably anything else you can put in there, and cooling. We've got a big change in the way that the data center is built in terms of cooling. If we go to the next chart here.
Yeah, before we do, Fred, but I think it's interesting that these are some of the largest consumers of tape systems today.
Yeah.
And clearly you mentioned economics, you mentioned energy, but I would also throw in the reliability of tape systems and also the longevity. You don't have to replace tape systems as frequently as other hardware. So it's interesting that these guys are on the cutting edge of technology, and they are the largest users of tape technology at the same time. So,
and that media life you mentioned, Rich, I think, correct me if I'm wrong, but you just formally announced earlier this year that the media life for LTO went from 30 to 50 years. Is that correct?
That's correct. Based on barium ferrite. Yes. Mm-hmm. That's correct.
So that's modern tape, 50-year media life now, and the drives last you, pick your number, 5, 7, 10 years. Your back end migration time to new technologies is greatly reduced from tape. And, the disk drives on the average sit on the floor 4 to 5 years before they're replaced or they fail. Right. And then, by the way, on disk, you have to move all the data. On tape, you kind of just roll the data forward to the next technology over time. So the migration on the back end to new technologies for tape is far easier than it is for disk drives.
And it's a substantial reduction in e-waste as well. So,
oh my goodness.
Yeah.
Yeah, we didn't have time to put that in there, but you're exactly right. I mean, it just goes on and on. I mean, it's a shame. We should take the advantage of this technology now that it's advanced as far as it has.
Okay, great.
So one of the things the hyperscalers are doing, beginning to do at least, is called RAIL, Redundant Arrays of Independent Libraries. Many of you hopefully know about RAIT, Redundant Arrays of Independent Tape. And RAIT spreads blocks of data across different cartridges. So you can read them all back in parallel and get a much faster aggregate data rate. RAIT is a big throughput benefit for high data transfer applications. 400 megabyte per second data rate on an LTO9 tape drive. If you stripe that across 4 drives, you could have the potential for 4 times the data rate for that tape file or object really that you had before. And that is a big number, 4 times the throughput. Disk can't touch that. The average disk data rates are 160 to 220 megabytes a second. Tape drives are 400 today, 400 megabytes a second. And you move 3 or 4 of those in parallel and you get, a gigabyte plus per second data transfer capability. And Rail takes us further. Not only does Rail move or store data in files or objects on different cartridges, but each cartridge is in a different library. And the libraries can be geographically spread to new locations. That's called geospreading. It goes around the world. And why is that? Because hyperscalers have data stored all around the world. So this gives you it's a little bit of a performance advantage, but a major availability increase. And this is a way to provide backup for the archive data. Remember we said earlier, archive data doesn't have a way to be backed up. This helps because it uses erasure coding. This is new to the tape industry, but erasure coding splits files or objects into blocks. They do call them chunks here. And you can look on the chart, block 1 goes in location 1, block 2, location 2, block 3, location 3, block 4. And now we're back to the location 1 again. And it stripes them all around here with parity. The parity is really the hash codes created through erasure coding. And it's much lower overhead than the RAID is for disks. So you can use a much higher percentage of capacity to bring availability to the tape world. And remember, we have 1 copy basically of the archive data today with this architecture that basically eliminates that problem. So erasure codes are cool. Hyperscalers are the first big user, but to anybody with a large cloud or object environment in multiple locations should be taking a look at Rail. Okay. So Rail is a way to provide availability also. If one of the drives fails, you can still recover with erasure coding. That's a good deal. It's got a way to recover the data like that. So it's a data recovery capability. For years, we've lived off of this 3-2-1-1 backup strategy. That's basically 3 copies of data, 2 media types, 1 offsite, and one of these 3 has got to be an air gap technology with no electronic connection. But backup was always applied to online data in that tier 1 and tier 2 part of our pyramid earlier. But backup was rarely applied to archival data. So the archival strategy is now beginning to appear. And this is another thing for the Active Archive Alliance to begin to focus on is availability for archives. Not just to make the archive active, but how can that engine now create the secondary copy? So for the archive strategy, 2 copies of data, they should be in 2 different locations. And it doesn't have to be all your archive data, but the archives that you think are going to be the most valuable ones from wherever they were originally created. One of those 2 should be air gapped in one of those 2 locations. So now we have a template to protect all data, not just the online data that we do backup and recovery from, on a regular basis every day or so. But now we extend it to the entire archive strategy. And now the whole pyramid has a data protection strategy to go around it.
And Fred, this is an interesting one. When you talk about air gap, Spectra a few years back was attacked by ransomware, and we were very public about it. But for about a solid week, we had to cut all access to the outside world because you've got to figure out what that malware is doing. Is it opening up backdoors to other dark players to get into your systems, which often happens. So were we not able to secure a copy on site and air gapped, we wouldn't, if we only had a backup copy in the cloud, we wouldn't have been able to access it for that first week because we cut all ties. So it's interesting thinking about this air gap and the role it plays, and then where physically you're air gapping too. So just continues to be an interesting conversation as the bad guys get worse and we have to come up with defenses that are better.
What a great point. You guys lived through this. You shared your experience with the world basically to let people know how to live through that. And you kind of led the way to this chart actually, Bob, as you know, to give us a strategy here to deal with everything. So great point. And you've got that written up and I think on your website somewhere also, or available to people to see just how Spectra recovered from that. It was a masterful job, and we've got to treat all data as valuable, unless it's off in that lower corner with all that junk that we don't know what it is. We better have a way to get it back at some point. Okay. Data center power is a big deal. Also, we know how much energy the hyperscalers are taking up right now. All data centers, about 3% of the world's power. New data centers are being built with concrete floors and overhead cooling to route cold air more efficiently. The older data centers on the left did it underneath the floor, hot aisle, cold aisle. That's a strategy still in use. But the newer, larger scale data centers, as you can see in the center, coming in with overhead cooling, the busway architecture, those are the ducts overhead to improve efficiency, to drive down the energy issue on this whole thing. And the breakdown on the right up here shows in your data center who's consuming what. And servers and storage are the big hogs here with energy consumption, 57% for storage and servers. If you look down at the smaller square below that, you'll notice what the consumption is per server rack. It's a 42U rack, by the way, and by SSD, HDD compared to tape. So the next advance here on this chart will show us, what's going on here. The best thing you want to do to save energy in your data center is virtualize and consolidate those servers if you can. And the second biggest thing is to move as much inactive data off of disk as you can to tape today. Tomorrow there might be something else, but today this is what we've got. And Rich, I think all the studies that you've done and that we've seen show 85 to 90% reduction in TCO and energy consumption when you move the dead data off of disk onto tape. Is that pretty much your?
Yeah, that's pretty accurate. The studies that we've done with Brad Johns, 87% less energy is consumed, tape versus disk. And the CO2 equivalence, or CO2e, is actually reduced by 97% over time. So huge energy reduction, big improvement in carbon footprint. And of course, TCO has always been there, but that's 78, 80% reduction as well. Yeah.
And I think you've got those studies published somewhere on your website, that or white paper area, that will let people go and find that. They're great studies, and we need to get into this now. The expense and the energy issues, the environmental issues are becoming overwhelming as IT gets bigger and bigger. Okay. So we're kind of back to disk and tape now, dealing with this whole secondary storage world. Disk is the active archive, tape is the rest of the archive world. There's nothing else there. And looking forward, I mean, we're going to look at the roadmaps here up to roughly 2035. Today we're on barium ferrite with tape. That's a path on its way to, it looks like 100 terabytes roughly through barium ferrite. Strontium ferrite's up to the demo was 576, I believe, Rich, right?
The demo was actually 580 with
580.
IBM back in 2020.
The
Right.
spec is 576.
Well, it fits within what we were able to demonstrate. Yeah.
So the Gen 14 spec for LTO over here is 576 terabytes on a single cartridge, non-compressed. So you can do the math and see what compressed does, but through the LTO family as defined, we're going to be able to run capacity per cartridge, it looks like, up over, up around 1.4 terabytes or 1,400 terabytes per cartridge.
Yeah, 1.4 petabytes.
1.4 petabytes on a single cartridge. So hang on, but tape looks like it's paving the way to go forward, and none of the emerging technologies have made that happen. We're on Gen 9, by the way, at 18 terabyte native, 45 compressed here. But the point is here on this chart, the roadmap for tape is the most defined and substantial one of any of the technologies going forward.
And Fred, of course, when these capacities increase, new generations come out, not only does it, provide the higher capacity and density, but reduces total cost of ownership and also requires less energy. So again, it's supporting really what's critical going forward, the economics, the energy, the capacity, longevity.
I mean, exactly right. This supports the entire secondary storage ecosystem that we talked about. Hardware costs, capacity, everything gets better as we migrate through these generations. So this is the advantage that the tape industry gives to everybody else, is to take advantage of these things get involved, start to use that and get the right data in the right place. And we now have a roadmap. I think if we called it every 3 years, we'd be out through about 2037 or so on this one. So we got a ways to go here. Let's optimize what we have at hand. Okay. So to kind of wrap it up here, what we're looking at is secondary storage really favors an active archive. An active archive, it means your large archive technology, ideally for archive data today, that is tape. And the active archive is the layer on that to allow you to access in very fast time frames the data you want to analyze and use and then put back in the archive because you're not going to use it for a while. And the dynamic access patterns through the archives is becoming much richer now with AI routines, everything else mining this data, building their data sets for their AI application software. And the archives are being mined. The archives are active again because of all the new things that are searching and trying to find valuable data in those archives. And it's not like we got archive data in the attic for 20 years. The archive data can become active at any point in time. And the active archive makes it very economically feasible now to get archive data permanently off a disk and into the secondary storage architecture, which is a layer of disk on top or flash. And then the home for all that data is the world of tape. So you can look at this chart later on when you review this, if you do, and see all the benefits of the active archive to the secondary storage world. But this is where we're at right now. And I think tape and disk will likely share the active archive load for the foreseeable future. Okay.
Well, thank you so much, Fred, for joining us today. That was incredible. Hopefully our audience got a lot out of it. And as you said, they can download a PDF of the webinar, listen to it again. Bob, thank you so much. It's great working with you on the Active Archive Alliance. And hopefully this was a lot of value for the end users out there. Thanks again, guys.
Absolutely. Thank you, Fred. Thank you, Rich. Thank you all for joining us.
Thank you, everybody.
Have a great day, everyone.